All right, let's get started with 5.3, properties of logarithms. And so we're going to start by listing all of the properties of exponents. And then from those, we're going to build the properties of the logarithm. So just as a review, if you have a base that's the same and you have two different powers, if you are multiplying the bases, you can add the powers. And then we've seen this one before. If you have a distribution of powers, that means you can multiply the powers as well. And then remember that the negative means you can flip it over, so 1 over b to the m. Okay, and then situation like this, m would distribute. And then the opposite of this one is that b to the m over b to the n means you would subtract the powers. And then lastly, we talked about the last couple of classes, anything in the world to the 0 power is 1. All right, so let's take all of these and flip them around so they're properties of logarithms. So property 1 here, remember that b to the 0 equals 1. So log base b of 1 equals 0. So any log, if the exponent is 1, power is 0. All right, on number 2, if the base and the exponent are the same, b to the first equals b. So this must be a 1. All right, the logarithm, if you have a base and the exponent are the same, they're going to cancel out, and the x will be all that's left. So we're left with the x here. And this works in both directions. b to the log b of x just equals x. Okay? All right, then we've talked about these 3 rules here. So if you are multiplying in a single logarithm, you can add in a 2 logs here. So this is the same as, or this is the reverse of b to the m times b to the n equals b to the m plus n, right? And then we have the division version. So if we are dividing within a single log, we are subtracting within 2 logs. And then we do have the power rule, bring that to the front. All right, so just some common and natural log properties. So the common log is when we have base 10. This is the button on your calculator that says log. So anytime we do not see a base, we assume it is base 10. So log base 10, remember, of 1, always 0. Since this is 10, 10 and 10 match up, so we would get 1. 10 and 10 match up, so those cancel. The x is all that's left. And same thing here, the 10 and the 10 will cancel, and you have an x. And the same thing works here because ln, that stands for log base e. So anything of 1 gives you 0. Log base e of e should cancel out and give you 1. And then we'll cancel and cancel, and we'll just have the x left over. All right, let's try some problems. So a, log base 10 of 10 will cancel out and give us 1. The natural log of 1, automatically, if it's of 1, we say 0. All right, on C, this is 10 to the log base 10, so those will cancel out, and we're left with x plus 8. D, this is e to the log base e, natural log, so those are going to cancel out, and we're going to have 2x plus 5. We're going to cancel out, and we're going to have x squared. And then we're going to cancel out, and we're going to have x plus 3. All right, let's try this again with the expansion rules. So what do we have here? So log base b of u squared square root of v. So first things first, we have multiplying in there. So let's expand these first. So log base b of u squared plus log base b of v. And I'm going to rewrite this as v to the 1/2. That's how you write square root using a power. And then we'll take the 2 and the 1/2 and bring them to the front of their respective logarithms. So 2 log base b of u of 1/2 log base b of v. All right, your turn. See if you can expand this problem. So hopefully we get log base b of x to the 4th plus log base b of y to the 1/3 this time. And so we'll bring those powers to the front. 4 log base b of x plus 1/3 log base b of y. Okay, so let's go the other direction with this. As long as the bases are the same, we want to combine them if it tells us to put this into a single logarithm. So first things first, let's take the powers and put them back up. So we've got log base b, 3 squared, the 2 at the top, plus log base b of u to the 4th. So we can put these together now. Log base b of, what's 3 squared? That's 9, u to the 4th. Return. So we have the natural log of x squared plus 3, and I'm sorry, plus natural log of y cubed. And so now we can put them together. We'll have the natural log of x squared times y cubed. All right, so let's expand these using the difference property. So the natural log of x cubed minus the natural log of y squared, and bring your powers to the front. 3 natural log of x minus 2 natural log of y. Your turn. Log, this is log base 10, a to the 4th minus log base 10, a to the 5th. We'll bring those the 4 and the 5 to the front. 4 log a minus 5 log b. All right, so let's go the other direction with the difference and put them together as a single property. So we'll have the natural log of x to the 2/3 minus the natural log of y to the 1/2. And so then we have the natural log of x to the 2/3 over y to the 1/2, just like that. And so your turn, give it a shot. Log a of 1/2 minus log b cubed. We'll have log of a to the 1/2 over b cubed. And this is also the same as saying log of the square root of a over b cubed. You can write it either way. Okay, let's put this all together when we have multiple logarithmic expressions. So first thing, of course, we got to put the 3 up top and the 2 up top. So we're going to have log base b of x cubed plus log base b of 2x plus 1 minus log base b of 4 squared, which will turn into 16. And so we're just going to go left to right. So we're going to have log base b of x cubed times 2x plus 1 times because of b plus symbol, and then divide because it's a minus all over 16. Those will all be part of your logarithm. Your turn, put it all together. We'll have the natural log of x squared minus the natural log of 3y plus the natural log of z cubed. Okay, and so we're going to go left to right here. So we're going to say the natural log. Now be careful with your order of operations. This is going to be, we just do these first two. We're going to say x squared over 3y plus the natural log of z cubed. The plus means we're going to times again. So timesing is going to go in the numerator. So we'll have x squared z cubed over 3y. Okay, looks like a little bit of a trick here because I don't see any multiplying here to expand, but this is factorable. So we could write this as x minus 3 and x plus 2 over x plus 6, x plus 1. All right, so we're going to say natural log of x minus 3 plus the natural log of x plus 2 minus the natural log of x plus 6. If it's in the denominator, we're going to say minus again, minus the natural log of x plus 1. So anytime you see a minus, it's in the denominator, plus it's going to be in the numerator. All right, last thing we're going to talk on here is the change of base formula. So any base can be rewritten in a different base, and we'll typically go log 10 or log natural log of the power over the base. So let's use this as an example. It's easier to see it this way. So we have log base 3 of 8. We can rewrite this as log base 10 of 8 over log base 10 of 3. And in fact, we have done this already because this is how we plugged it into all of our calculators. So let's grab our calculators and round this to, I think it said 4 decimal places. So we're going to do log 8 close our parentheses, divided by log 3, enter, and 1.8928. Approximately equal to 1.8928. All right, your turn. No, one more for me. Log base 4 of 17. So we can rewrite this as log base 10 of 17 over log base 10 of 4. Plug it into our calculator. 17 over 4. Log of 17. Close our parentheses. Divided by log base 10 of 4. And we have 2.0437. Did I get the 7 right? I did. All right, your turn. Wrap this up. All right, so hopefully you said log base 10 of 34 over log base 10 of 7. And so this will be approximately equal to, since we're rounding, 34 over 7. So 1.8122. All right, that'll do it for today. Good job.